integral cos cube x sine squared x dx. It's a similar integral. What will you do? Well, cos cube x sine squared x. Cos cube x can be written as cos squared x times cos x. That means this will be cos squared x times sine squared x times cos x dx. Then that cos squared x need to be converted to sine squared x using the identity that we already know. Alright, let's do that. Here the power of cosine is odd and the power of sine is even. So an even power of cosine can be converted to sine. So what we will do is, we know cos squared x equal to 1 minus sine squared x. An even power of cos can be converted to sine squared x. So integral cos cube x sine squared x dx will be written as how? It is integral cos squared x times sine squared x times cos x sine x. We took one cos x and put it at the end. Now this cos squared x can be changed into sine squared x using this identity. Let's do that. So convert cos squared x to sine squared x. That is, this cos squared x now become 1 minus sine squared x. Integral 1 minus sine squared x times sine squared x times cos x dx. Now we can substitute. Substitute what? We can substitute sine x equal to u. So substitute sine x equal to u. Find the differential of both sides. Differential of sine x is cos x dx equal to du. So this cos x dx then will become du when sine x becomes u. And that gives you integral 1 minus u squared times u squared du. Now we can distribute the u squared. That gives you integral u squared minus u to the power of 4 du. And this can be easily integrated, is that right? Integral u squared du is u to the power of 3 over 3 minus integral u to the power of 4 du is u to the power of 5 over 5. Well, you can now replace u by our substitution sine x. So our u equal to sine x. U cube is sine cube x divided by 3 minus u to the power of 5 over 5 become sine to the power of 5x over 5 plus c. That's again a simple method, the same as the previous one. Alright, let's try another one. Integral sine cube x dx. Now here, there's no cosine. So how are we going to do that? Any clue? Think about it. Integral sine cube x dx. The power of sine is odd, which means I can write this as sine squared x times sine x. Now, if I have a sine x at the end, the idea is to make it serve as dx or du. And in order that sine x may become du, you must have cos in the original integration. That means the sine squared x we have here must be changed in terms of cos squared x. That's right. Okay, let's do that. We write sine cube x equal to sine squared x times sine x and then convert this sine squared x to cos squared x. Alright, that will be integral sine cube x equal to integral sine squared x times sine x dx. And write sine squared x in terms of cos squared x. What does that become? Sine squared x is 1 minus cos squared x. So that will be, replace sine squared x by 1 minus cos squared x. That will be integral 1 minus cos squared x times sin x cos x. Well, we can now do a substitution. What is a substitution? We can make cos x equal to u so that sin x dx will have the du form. So our substitution is cos x equal to u. Then differential of cos x is negative sin x dx. Negative sin x dx equal to du. Therefore, what is sin x dx? Sin x dx is negative du. When cos x is replaced by u, sin x dx become negative du. So what does the integral become now? That will be integral 1 minus cos squared x become u squared times negative du. And the negative sign comes out of the integration. Or we can actually change it. When you multiply this negative inside this parenthesis, negative 1 minus u squared becomes u squared minus 1, isn't it? Negative 1, negative u squared, positive u squared. So it is integral u squared minus 1 du. All these simple algebraic techniques are very important. Now we can integrate it. Integral u squared du is u cubed over 3 minus integral 1 du is u. So that will be u cubed over 3 minus u plus c. And replace our u. What's our u? Our u is cos x. That will be cos cube x over 3 minus cos x plus c. And that is very simple that way. Now, in the same way, you can also integrate integral cos cube x dx can be integrated. Alright, let me give you a challenge. Can you integrate sine to the power of 5x dx like this? Try that on your own. Integrate sine to the power of 4x. What change will be there? You will write, not sine to the power of 4x, sine to the power of 5x. We write sine to the power of 5x as sine to the power of 4x times sine x, and then change sine to the power of 4x in terms of cos x like this. If sine squared x is 1 minus cos squared x, sine to the power of 4x will be the right hand side raised to the power of 2. Alright, try that on your own and see whether you can complete it. Okay, let's integrate this. Evaluate the integral. Integral cos cube x over 3. Well, this is the same as integrating cos cube x dx. The only difference here is it is x over 3. That doesn't make much difference. So what's the method here? Write it as cos squared x over 3 times cos x over 3, and then change the cos squared x over 3 in terms of sine squared x over 3. So we write cos cube x over 3 equal to cos squared x over 3. I omitted that here. It must be cos squared x over 3 times cos x over 3. And then convert the cos squared x over 3 to sine squared x over 3. Not like this. And convert cos squared x over 3 to sine squared x over 3. Alright, read that correctly. Once again, we write cos cube x over 3 as cos squared x over 3 times cos x over 3. And then change that cos squared x over 3 in terms of sine squared x over 3. Alright, let's do that. Integral cos cube x over 3 dx equal to integral cos squared x over 3 times cos x over 3. And we need to change this cos squared x over 3 in terms of sine squared x over 3. How? Cos squared x over 3 is 1 minus sine squared x over 3. That's right. Cos squared x over 3 is 1 minus sine squared x over 3. Let's replace that over here. So that will be integral 1 minus sine squared x over 3 times cos x over 3 dx. Well, we got what we wanted. We can now do a substitution. What is the substitution we can do here? Well, we set it up for it. So our substitution is sine x over 3 equal to u. So substitute sine x over 3 equal to u. Alright, tell me, what is the differential of sine x over 3? The derivative of sine x over 3 will be cos x over 3 times the derivative of x over 3. And derivative of x over 3 is 1/3. So it will be 1/3 cos x over 3. You see that? So the differential of sine x over 3 will be cos x over 3 times 1/3 dx. The derivative of sine x over 3 is cos x over 3 times the derivative of x over 3 is 1/3 times dx. So cos x over 3 times 1/3 dx equal to du. What we need is this, cos x over 3 dx. So cos x over 3 dx can be obtained by multiplying both sides by 3. And that will give you cos x over 3 dx is 3 du. There you go. And so when sine x over 3 becomes u, cos x over 3 dx becomes 3 du. Let's replace that. That will be integral 1 minus u squared. Is that right? Sine x over 3 is u. Sine squared x over 3 is u squared times 3 du. And 3 can be taken out of the integral. That will be 3 integral 1 minus u squared du. You can integrate that. Integral 1 du is u minus integral u squared du is u cubed over 3. So that will be 3 times u minus u cubed over 3 plus c. And replace our u. What is our u? U is sine x over 3. That will be 3 times u is sine x over 3 minus u cube is sine cube x over 3 plus c. And that will be, if you want, just distribute that. It will be 3 sine x over 3, and then you distribute here, the 2 3's will cancel. So that will be 3 sine x over 3 minus sine cube x over 3 plus c is the result. Alright, another one. Evaluate the integral sine